Hi everyone! Today we'll take a closer look at Chapter 4, Test Analysis and Design. We will learn the section Decision Table Testing in the topic Black Box Test Techniques. Let's begin. This video is a part of the ISTQB Foundation Level Preparation course on Udemy. For more information, check the description below the video. We will find out what study materials we can use for self-study. Also, together with you, we will find the correct answers to several ISTQB questions with the help of the theory. Let's begin with study materials. As with the equivalence partitioning and BVA, the decision table testing is described in the syllabus in a very abstract style without examples and additional explanations, which are necessary for the questions of the K3 level. That is why we created this video to give you additional explanations on how to apply the technique in practice. However, we will start with self-studying. Additionally, you can read information about the decision table testing in the book Foundations of Software Testing ISTQB Certification by Rex Black. This is one of the authors of the exam, and his explanations will be very helpful. Within the thread, it doesn't matter which version of the book you find, 3rd edition or 4th edition, both have valid information. The problem is that the books are not freely available as they are quite expensive. But maybe they are available for your organization, or you might be lucky enough to find at least the 2011 edition. Now let's learn how you can use the theory written in the syllabus in practice. You can pause the video and familiarize yourself with the content of the slide. We presented the theory of the syllabus in a logical sequence of actions that must be done in the simplest test cases on decision table testing. It is important to note that using this technique in practice and answering ISTQB questions are two very different things. At work, when you use the test design technique, you will need 1. Analyze the requirements, 2. Determine conditions and actions, 3. Build a decision table. And it is in the 3rd step that there is a main difference. In ISTQB questions, the decision table is already built. Very often, you need to analyze whether it is built correctly, find a mistake in it, or simply calculate the coverage. And for this, we still need to know how to build a decision table. That is why we will start our tutorial with the construction of 2 tables, based on the requirements similar to those that you can meet in ISTQB questions. You can pause the video and read the requirements, and try to build a decision table yourself, and then compare the results. At work, you can use AI. It copes quite well with such tasks. However, you must know how to build tables in order to be sure that the AI does not make mistakes. And on the exam, you will not have the opportunity to use artificial intelligence. Therefore, we will go through all the steps of using decision table testing to derive test cases. The first step is to build a full decision table that has enough columns to cover every combination of conditions. We need to define the conditions and the resulting actions of the system. These form the rows of the table, usually with the conditions at the top and the actions at the bottom. Let's find the conditions in our requirements. For beginners, this is quite a difficult task. That is why in the ISTQB questions are built for us. In short, we have 2 conditions. This may or may not be the first attempt at the exam. A candidate may or may not pass the exam. That's how we write in table column. Conditions have only 2 values, yes or no, and accordingly we write them in such style that one condition corresponds to Boolean values, often in the form of questions. Let's check the actions now. Those are easier to define in the requirements. And we can define 3 actions. Grant access to practical exam. Offer a second try and ban from attempting for 1 month. This is most difficult and the most critical point in the decision table test design technique. If the conditions and actions are incorrectly defined, all subsequent steps will lead to incorrect results. The next step in building a complete decision table is determine the combinations of binary values for the conditions. In reality, values are not always binary. Sometimes one condition can have 3 or more values, but this greatly complicates the construction of the table. Therefore, in ISTQB questions, the conditions are mostly binary. If we have 2 conditions, each of which has 2 values, true or false, then the table will have 4 possible combinations: true, 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 false, false, true, false, false. If there were 3 conditions, then there would be 8 combinations. If 4, then 16. We'll talk about the formula a little later in this video. Let's move on to the next step. In the vast majority of cases, the sign X indicates that the action must take place. If the action cannot take place, then the cells are left empty. The full decision table will look like this. The first rule is, if this is the first attempt at the exam, and the exam is passed successfully, then access to the practical exam is provided. We mark the action to provide access to the practical exam with an X, and we leave the other 2 actions empty. The rule does not say anything about whether it should be the first or second attempt. Accordingly, the mark X on the second combination as well. We do the same with other combinations of conditions: true-false, false-true, false-false. This is called a full decision table. We have all possible combinations of conditions. We define actions for each of the combination. Once the complete table is created, we can simplify it, and we advise you to start with the deleting columns containing infeasible combinations of conditions. But in our requirements, there is no mention of any restrictions or impossible combinations. There are only conditions and actions. With the help of this, we can easily determine which action refers to which combination of conditions. Sometimes there are conflicts in tables based on conditions. For example, some combination would lead to 2 actions or 2 contradictory actions at the same time. But not in our case. Accordingly, we skip this step and move to the merging columns, in which some conditions do not affect the outcome, into a single column. For this step, you first need to pay attention to actions, and to find those rules where there are the same actions and the same results. In our case, these are the first and third rules. As you can see, access to the practical exam is provided in both cases. After that, we look at the conditions. That is, if the theoretical exam is passed, then access to the practical exam is granted. That is, it does not matter whether it's the first attempt or not. Accordingly, instead of true-false marks, we can put a dash. As a result, we get 2 identical columns, which can be merged into one. This is how the table is simplified. You may have the question, for what purpose do we need to simplify the table? And the answer to this question is in the next step. In decision table testing, the coverage items are the columns containing feasible combinations of conditions. To achieve 100% coverage with this technique, test cases must exercise all these columns. As you can see, after simplifying the table, we have only 3 columns, 3 combinations that lead to different actions. Accordingly, we only need 3 tests to achieve 100% test coverage. We write only 1 test per column per the rule: pass the exam on the first attempt, fail the exam on the first attempt, fail the exam on the second attempt, and we do not need to separately test the scenario of passing the exam on the second attempt. Coverage is measured as the number of exercise columns divided by the total number of feasible columns and expressed as a percentage. We have 3 columns and 3 rules, and we have 3 tests, each of which covers one of the rules. Accordingly, the test coverage is 100%. If we did not simplify the table, then we would have 4 columns and 4 rules. Accordingly, with 3 tests, we would achieve only 75% coverage. The second column would need an additional test. Pass the exam on the second attempt. This is why the tables are simplified. To cover more conditions and actions with fewer tests. This may not seem important, but let's take another example, and let's complicate the description of the task with just 1 sentence. You can pause the video and read the requirements, and try to build a decision table yourself, and then compare the results. We start from scratch, like last time. And we start with the full decision table. We need to define conditions and actions. This time, we have 3 conditions, 2 exams that can be passed or failed. As we said, this is the most difficult step, because there are many options for how to build the table. So, we defined 3 conditions: theoretical exam passed, practical exam passed, and the first attempt at the exam. Let's define actions now. Again, there are several options for defining actions, but we will highlight 4. Issue a driving license, request additional driving lessons, request to take the exam again, ban from attempting for 1 month, and now we can move on to the next step. Mark the conditions as yes or no, or true or false, or other marks that you like better. This time, we have 8 combinations in total. As we said, with each subsequent Boolean value of the condition, we get twice as many combinations. That is, we have 2 states, true and false, and we have 3 conditions. Accordingly, we have 2 in the cube, multiply 2 by 2, and by 2. This is important to understand in order to build complete decision tables. If you have one condition that can be true or false, then you only have 2 options, true and false. Since you have 2 conditions, then you already have 4 options, 4 combinations of true and false. According to each additional condition, the number of combinations increases twice. 8 if 3 conditions, and 16 if 4. Accordingly, now it becomes clear why to simplify the tables. After all, the more combinations, the bigger and more complicated the table. The authors of ISTQB tests mostly understand the complexity of using the decision table technique, and therefore, in most questions, you will find 2 or 3 conditions. However, there are exceptions. For example, ISTQB has questions like this where you have 7 conditions. Yes, there are certain limitations in the description, but they do not simplify the situation. The full table looks like this. It's very difficult to create it, and even worse, it's quite easy to make a mistake. Therefore, our advice is as follows. If you are unlucky and there is a question with 4 or more conditions on the exam, we advise you to skip it and come back to it when you answer all the other questions. All questions have the same value, 1 point. And finding the correct answer to a question with 4 or more conditions can take much longer than 5 minutes. But mostly, it is not the case, as you can see. Both ISTQB examples have only 3 conditions. In most cases, the tables are built for you, and you only need to analyze them and answer the question. Let's go back to our table. Long story short, we have 8 possible combinations of the states of conditions. Let's move on to the next step. We need to label the consequences of each combination with the X sign. Accordingly, we read the conditions carefully and mark each action with an X when the action must take place according to the conditions. The first rule is as follows. If the candidates have successfully passed both the theoretical and practical exams, the driving license is issued. So we put an X mark on the action, issue a driving license. The rule does not say anything about whether it should be the first or second attempt. Accordingly, we mark X on the second combination as well. And in this way, we put all 8 marks. This is the most difficult and longest stage. The more rules and conditions you have described in the requirements or user story, the more difficult it is to build a table. Let's move on to the next step. Now we have to simplify the complete decision table. We start with deleting columns containing infeasible combinations of conditions. This time, we have such conditions. We have this contradictory requirement. Only candidates who have successfully passed the theoretical exam are granted access to the practical exam. In fact, it can be both an action and a constraint. But for our example, we decided to use it as a constraint. The rules from the 4th to the 8th provide that the theoretical exam is failed. After that, there is a condition regarding the practical exam, which is twice true and twice false. And we can replace these true and false with NA. This means that the condition is infeasible for a given rule. And when we do this, we will get 2 identical columns that can be merged. Rule 5 and Rule 7. Now they are the same and we can delete one of them. Same with Rules 6 and 7. If the theoretical exam is failed and it was not the first attempt, then the candidate is banned for 1 month. One of these columns can be deleted. This is not an ideal example of deletion because there are rules that would delete all columns in general, but we wanted to show you that there is no need to rush to delete. First, you should mark the columns as NA. Thus, we have only 6 columns left, which significantly reduces the number of tests required for 100% test coverage. Let's move to the next step. Merging columns in which some conditions do not affect the outcome into a single column. As in the previous example, the first rule and the second rule can be merged into one, regardless of whether it is the first attempt or not. If both tests are passed, then the driver's license is issued. Thus, we only have 5 columns in the table, and the last step remained. To achieve 100% coverage with this technique, test cases must exercise all columns. Accordingly, 5 tests are needed to test 5 columns. As we mentioned earlier, the decision table technique is quite complex. After all, the decision table itself is very difficult and time-consuming to build. Luckily, in most questions, the table is already created and we only need to analyze it. That's all. We discussed all the theoretical and practical aspects of applying the decision table testing test design technique. We hope that it is now clear to you and it will be easier to answer ISTQB questions and also to use it in practice. Let's try to use what we have learned about the decision table test technique in the example of questions from the official ISTQB exam samples. There is a 100% chance of having one question of K3 level on the exam ticket related to the decision table testing. The K3 level questions are the most difficult. Some you can answer in 1-3 minutes, but some questions are so twisted and confusing that you can spend 10 or more minutes on them. In the new sample exam version 4.0 document, we can find the following question. Those who want to try to answer the question themselves can pause the video. Let's find the answer to it in the study materials. In previous questions about black box test design techniques, equivalence partitioning and BVA, we started with test by reading the description of the question very carefully to find the information that can make changes to the existing checklist. The situation is different with the decision table testing technique. We don't need to create a decision table, we need to analyze the existing one and find the right answer. That's why, in most questions, we either do not follow the checklist at all or use only 1 or 2 steps from the checklist. As we said before, creating a table based on requirements is quite a long and complex task where it is very easy to make mistakes. That is why, in ISTQB questions, the tables are generated for us. This greatly simplifies the search for correct answers to questions. For example, this question should be based only on the feature description of the Customer Relations Management System. Find rules that describe an impossible situation. Let's try to do it. We have 4 answer options and we have to check whether the rule in the table meets the conditions in the requirements. For this, we need experience in building tables on our own. The first rule is, anyone can rent a bicycle, but members receive a 20% discount. As we see, the condition of being a member is set to a true, and the action 20% discount is marked as such was happened with a cross mark. Accordingly, these table rows meet the conditions in the requirements. Let's check the next condition. The second rule is, however, if the return deadline is missed, the discount is no longer available. As we see, the condition of missed deadline is set to a false, and the action 20% discount is marked as such what happened with a cross mark. Accordingly, these table rows also meet the requirements. Let's check the next condition. The third rule is, after 15 rentals, members get a gift, a t-shirt. As we see, the condition of the 15th rental is set to a true, and the action gift t-shirt is marked as such what happened with a cross mark. Accordingly, these table rows also meet the requirements. Thus, the fourth rule in the description table is valid and describes the possible variance of situations correctly. We will not consider each answer option and each row in the table in detail. With the same steps, we can determine that answer option B describes a possible situation. Same as answer option C with the sixth rule. The terms and conditions are valid and meet the requirements. The impossible situation is described only in answer option D. As we see, the condition of being a member is set to a false, just like in the previous rules. But there is one difference. Rules 5, 6, and 7. The action gift t-shirt is left blank. The action hasn't happened. But in the rule 8, the action gift t-shirt is marked as such what happened with a cross mark. Since the third in the requirements is described as that, after 15 rentals, members get a gift, a t-shirt. This means that only members receive a t-shirt. Accordingly, answer option D describes an impossible situation. After 15 rentals, not a member got a gift, a t-shirt, and is the correct answer. All other options, A, B, and C, are valid and describe possible situations. As you can see, in this example, we did not need to follow the checklist because the description table was built for us, and it was only necessary to analyze its validity. Let's check one more example of the ISTQB question. In the new sample exam version 4.0 document, we can find the following question. Those who want to try to answer the question themselves can pause the video. Let's find the answer to it in the study materials. As we can see, the question is similar to the previous one. Sometimes the table is already created for us, and we need to determine the level of test coverage. Accordingly, we cross out two main steps from our checklist, and we leave only the last step. In decision table testing, the coverage items are the columns containing feasible combinations of conditions. To achieve 100% coverage with this technique, test cases must exercise all these columns. So we start with the first test. The first condition is cholesterol equals to 125, which aligns with two rules. Rule 3 and 4 are both rules that require a cholesterol level of 125 to 200. We mark rules 3 and 4 against the first test, and must now look at the next condition. Blood pressure equals to 141. As you can see, the third rule involves a blood pressure of less than 140. Accordingly, the first test case covers only the fourth rule, and thus we need to consider 4 more test cases. Again, as in the previous question, we will not explain each test case step by step because it's quite obvious. Just to note that first two tests cover Rule 4. The third and fourth test cover Rule 2. The fifth test covers the fifth rule. Now that all test cases have been analyzed, we already did this at the beginning of the tutorial. It is best to illustrate this with the help of a table. As you can see, we have a lot of rules. The first and third rules are not covered by the tests. The second rule is covered twice, but the fact that we have 2 tests for one rule does not affect the final coverage. It doesn't matter how many tests per rule, it only matters if the rule is covered by the tests or not. There are 5 rules in total, and only 3 of them are covered by tests. One rule is 20%. Accordingly, the test coverage will be 60%. And this is answer option B. As you can see, although decision table testing is a more complex technique than equivalence partitioning and BVA, the questions on it are simpler, provided that you do not need to build a complete table of conditions and actions. Let's check another example of an ISTQB question. In the new sample example version 4.0 document, we can find the following question. Those who want to try to answer the question themselves can pause the video. This question, which at first glance is simple, is actually much more complicated than the previous one. After all, we have a shortened table of conditions and actions, and we need to build a full table that was before the reduction. From our checklist, we only need one item, merging columns in which some conditions do not affect the outcome, into a single column. So we have a table in which there are 3 dashes. we need to separate the combined columns into separate ones. Instead of a dash, we can write true or false. Thanks to this, it will be easier to illustrate how a complete table of conditions and actions is formed. In this way, two columns are formed from the first column, one of which must have the condition first attempt at the exam. True, and the other column will have it as false. Accordingly, the first column is cleared, and we can proceed to Rule 4, dividing it according to the same steps. And thus, instead of 3 columns and 3 rules, we got 5. The next rule is complicated. As you can see, 2 conditions are combined into one. The condition, first attempt at the exam, is marked with a dash, and the condition, practical exam passed, is marked with a dash. And here it is important not to make a mistake and disconnect both conditions in a row. First, let's separate the first condition in the same way as before. As a result, we will get 2 new columns, one is marked as true, the other as false. And as you can see, as a result of that unmerge, we got 2 more columns with a dash. Accordingly, we will get 2 additional columns. First, let's note that both can have a third condition. Practical exam passed, both true and false. In this way, we will get 8 columns instead of 3 that we had at the beginning. As we said, this question is much more complicated than it seemed at first glance. The last step is to search for conflicting conditions, and it doesn't take long to find them. The 6th rule has all the conditions as false, and the corresponding action, request to take the exam again. The 8th rule also has all 3 conditions as false, but a completely different action, request additional driving lessons. Thus, answer option D is correct. The false, false, false conditions will show that there are contradictory rules in the decision table. Even this difficult question, in our opinion, is much simpler than the equivalence partitioning and BVA, because it has much less ambiguities and contradictions. It is almost never necessary to build a decision table from scratch in ISTQB questions. Accordingly, we rarely go through all the steps in our checklist. Still, it's very important to know exactly how to create a decision table, because at work you will have to create them yourself. Also, without understanding exactly how to create a decision table, it will be almost impossible to solve the questions of ISTQB. For the topic Black Box Test Techniques, we have about 50 questions in total. About 10 of them will be related to the section Decision Table Testing. It is more than enough for practice. Well, that's the end of today's tutorial. We hope to see you in the next lecture.